on the outcomes of visual inspection for defining the safety upgrading strategies for Chimanimani District. My name is Hui. I'm the project coordinator in UNESCO ROSA, and I will be the moderator today for this webinar. So first, I would like to remind you about some housekeeping rules. So the meeting will be recorded and held in English. Please use your chat box to communicate with the webinar organizers. And if you have any questions during the presentations, please feel free to write them down in the Q&A box or in the chat box so we can address them shortly after the presentation during the Q&A session. And also during the Q&A session, please raise up your hand to ask the questions, and we will unmute your microphone to allow you to speak. Thank you. So now here comes the agenda. So the session will last around 1 hour and a half. At the beginning, we will have the welcome remarks from Dr. Koen Verbiest from UNESCO Regional Office for South Africa. Then the team of experts will provide the technical presentations around the VISUS. Firstly, Dr. Jaya Torres will provide the presentation on VISUS implementation in Chimanimani District. Then Dr. Patrick Madison will present the VISUS results in Chimanimani District. After that, Prof. Stefano Grimas will talk about the VISUS for defining safety upgrading strategies at the territorial level. And then Mr. Webster Guminoga and the engineer Prosper Marindico as the representatives of the local experts from the University of Zimbabwe will share their experience and lessons learned from the VISUS. After all this, we will have a Q&A session for discussion, and then we will have the final remarks, from Mr. Absalom Chinuna, representing the Ministry of Primary and Secondary Education, and Mr. Nazan Nkomo, representing the Department of Civil Protection. And after all this, we will finally have the closing remarks from Ms. Sanina Muziganwama, representing UNOPS. Okay, so now let's have the welcome remarks from Dr. Koen Verbiest, the program specialist from UNESCO Regional Office for South Africa. And unfortunately, as you know, due to the current special pandemic situation, Dr. Koen Verbiest could not join us in person today, but he recorded his welcome remarks, and I hope we can watch it together. Please, our IT colleague, can you play it? Thank you. Magnali, can you reshare the slides and turn on the computer audio? Thank you. We cannot hear anything. It seems that we meet some technical problems. Please wait for a few minutes. Thank you for your patience.
I just seeing that I was able to join on time. So if you want, I can also give the opening remarks directly, if that's okay.
Yeah, sure. Thank you, Kun.
All right. So I can't put on my video. If maybe somebody, if not, I will just give the presentation like that. So I would just like to welcome everybody, colleagues, ladies and gentlemen. And I'm just very pleased to welcome you here. I think somebody is trying to share the video now. Okay, I can continue. I just wanted to highlight, that I'm very pleased to welcome you here to join this webinar and to be able to present the findings from the visual inspection for defining safety upgrading strategies, or VISUS, that was conducted in learning facilities in the Chimanimani and Chipinge districts earlier this year. And this follows the VISUS initiative that UNESCO launched in October 2021 as part of the Zimbabwe Dire Recovery Project, or ZIRP, funded by the World Bank and managed by UNOPS. I would first like to thank the World Bank and UNOPS for supporting this initiative through the ZIRP, but of course also would like to thank the support from different governmental ministries and agencies to participate and support this important initiative. Ladies and gentlemen, natural hazards often damage or destroy school infrastructure, threatening educational opportunities and risking the lives of school children. It is therefore our collective responsibility to ensure that the safety of all children in schools is prioritized. As part of its mandate, UNESCO is actively engaging in empowering schools and their communities to identify hazards they are exposed to, map their vulnerabilities and capacities, and enhance school safety. To do so, UNESCO promotes a multi-hazard school safety assessment methodology called VISUS, and which stands for Visual Inspection for Defining Safety Upgrading Strategies. The methodology was developed by the UNESCO Chair on Intersectoral Safety for Disaster Risk Reduction and Resilience, Sprint Lab at the University of Udine in Italy. Ladies and gentlemen, studies of disaster trends and the likely consequences of climate change suggest that each year, 175 million children are likely to be affected by natural disasters alone. During the cyclone Idai, children were affected, and evidence of destruction is still there in the schools in the two districts, with more than 140 schools that were affected by the floods and the landslides that occurred in the area. There is a clear need for a methodology that identifies individual vulnerabilities in terms of site, structural performance, non-structural issues and functionality for every single school, while developing a regional and national database at the same time. In response to this, VISUS is used as an effective decision-making tool for planning risk mitigation actions at the regional scale, but it remains grounded in local context and needs. The methodology also assists in making investment decisions to strengthen the safety of schools efficiently and economically. So far, the VISUS methodology has been piloted in more than 8 countries worldwide, with Zimbabwe being the second country in Southern Africa after Mozambique to have used the VISUS assessments. Ladies and gentlemen, UNESCO is committed to building the scientific knowledge base to help countries in disaster risk reduction. This can only be achieved with well-established partnerships and support from the relevant government ministries and departments. In partnership with UNOPS and the World Bank, and with support from the Ministry of Primary and Secondary Education, as well as the Department of Civil Protection, UNESCO with its team of international experts, together with local experts from the University of Zimbabwe, managed to conduct the VISUS assessments in Chimanimani and Chipinge districts during October 2021. In total, 15 primary and secondary schools and staff quarters from Chimanimani and Chipinge district were assessed. The findings provided the identification of critical issues that shall be presented today, and that can provide the base for them to be addressed. As a milestone of the VISUS initiative, this webinar seeks not only to present these findings, but also to find a way to upscale the assessments to other districts that are prone to the recurrent disasters. It is our hope that through the VISUS initiative, UNESCO will support Zimbabwe to continue its effort to identify hazards that schools are exposed to, map their vulnerabilities and capacities, and enhance school safety. Therefore, I would like to wish you an engaging session and also a fruitful discussion on the way forward. Thank you very much.
Thanks a lot, Kun, and thank you very much for reconnecting in time. So I trust now the audience understands the general background of the VISUS initiative in Zimbabwe better. And so now we will have the presentation from Dr. Jaya Torres. on how the VISUS was implemented in the Chimanimani district. So Dr. Jaya Torres holds a PhD on risk and emergency management. He has been involved in the activities concerning the development of national strategies for disaster risk reduction, school safety, early warning systems, and the promotion of the scientific cooperation and capacity building for disaster reduction. He has played a responsible role on the design, the conception, the development, and the implementation of the UNESCO's VISUS methodology for assessing school facilities in the context of the DRR and the CCA. So now you have the floor, Dr. Jaya Torres. Thank you.
Thank you, Hui, and thank you everybody for connecting today. It's a pleasure to be here. I just want to start sharing my video and my presentation. So my video, I'm not allowed by the presentation. It seems that everybody can see it. Just let me, just 1 minute. Okay. So thank you, everybody. It is a pleasure to be here today to talk about the VISUS implementation in Chimanimani District. So we're going to be dividing this technical presentation on 4 different steps. The first one, I'm going to be talking just really general about what the VISUS is and how we implement it in Chimanimani District. Then Dr. Malisanchi will be explaining the main results that we found in the 15 schools that we visit. Then Professor Grimas will be talking about, how these results can be used for planning and decision-making processes, and some recommendations for scaling up this VISUS methodology pilot to a more bigger level. And then we're going to have some of the recommendations from the colleagues of the University of Zimbabwe, who have been also involved very deeply in the development of this implementation in Chimanimani District. So I would like to start by telling you a little bit why we are doing this thing. So as you know, Zimbabwe has been signing some of the global agendas and the global commitments on school safety, notably the Sustainable Development Goals, where quality education, goal number 4, has been defined to ensure inclusive and equitable quality education and promote lifelong learning. And one of the elements that we have in the SDG 4 on quality education is the need to build and upgrade educational facilities. Similarly, in the framework of the what we will call the DRR framework, the Sendai framework for disaster risk reduction, schools has been identified as one of the main targets in order to be protected when we are talking about critical facilities. So we are putting schools at the core of the development, and this is why we are doing this job in Zimbabwe, in order to help Zimbabwe to secure SDGs and to secure the targets and indicators that has been agreed on the Sendai framework for disaster risk reduction. Why we have been selecting the VISUS methodology for this specific task about to try to understand what is happening in the schools of Zimbabwe. The first one is because, even countries that has a lot of capacities in terms of budgetary and as well on human resources are being taking very long to take assessment of all of the schools that they have been This is the case, for instance, of Japan, on which one only for a specific hazard, that was the seismic hazard, took more than 15 years to assess the 100% of their schools. So we thought at UNESCO at that moment that it was very important to have a methodology that allows us to have a real clear understanding about what is happening in our critical facilities, notably schools, but that will give us an understanding in the really short time. So we will need something that will be more pragmatic, but at the same time will give us information that will allow us to take decisions and implement risk-informed investments. So this is why we came to the VISUS methodology. So the VISUS methodology tries to really answer questions about why it is important, how we're going to implement it, and what I need to do. This is based on one of the core pillars of the comprehensive school safety framework, that is the pillar 1 on safe learning facilities. The idea is to try to understand better how is the situation in the physical environment in terms of the vulnerability of that specific school to that specific physical environment. So one of the areas that we check is not only the school complex, the walls that we normally have in the building, but as well where the school is located, the buildings that are in that school complex, and as well the green areas or school yards. So this is one methodology that would like to provide information on the physical environment of schools. But not only on a specific hazard. Today, since 2015, since the adaptation of the Sendai framework, and after the Global Assessment Report of 2019, we have been taught and we have been realized that these approaches of hazards to hazard has to be stopped, because hazards don't stop when something happens. Hazards are interconnected. Hazards are can be compounded. And this is why the VISUS methodology took a multi-hazard approach, an integrated approach that understands the vulnerability of school facilities, not for a specific hazards, but for the global set of hazards that will be affecting the schools in that in the specific area, in this case of Zimbabwe. So we are assessing schools in terms of the what we will call the 4 elements plus 1. So hazards that are related to the air, like earthquakes, hazards that are related to the air, like windstorms, cyclones, hazards that are related to water, like floods, flash floods, etc. Hazards that are related to fire, like fires that can happen internally in the school or around the schools. And as well, we say the plus 1 because it has been proof historically that many of the schools are not having issues of security due to a specific hazard that has been triggered, but also because they have been having a lack of maintenance, lack of the different elements that will allow to keep the security of those schools in the long term. So we want to check how the lack of maintenance or a bad maintenance is putting the life of kids and the educational community in danger. So what are the main issues that we normally are evaluated within the VISUS methodology? So one is the first, the global structure of the specific building, some local structural problems that we can find on those specific buildings, some functionality, some non-structural elements that can create problems in the school, as well as some functional problems. For instance, the possibility to access or to egress for the schools in the case of that hazard hit the specific school. But similar, we assess as well the site. So elements that can affect the school from outside the school itself. So things that can really generate problems or complications in the case of that hazard will be triggered around the school. So these are the 5 elements that we try to solve in a multi-hazard context. So where are we gonna find the VISUS methodology in the whole level of knowledge of school assessments? So you can have the first starting point that is like the level 0, where you will have desk analysis of available documentation that will allow you to have as an output, some preliminary classification, but you are not really expecting the schools. You can have the bottom level that is really a detailed investigation and design, that is, for instance, what I was presenting about the Japan case. On that one, you really have detailed data acquisition and quantitative analysis that will allow you to have an in-depth specific assessment, safety design, and detailed cost quantification. But as I mentioned at the beginning, all of this process can take a lot of time. For instance, for Japan, as I showed, it was 15 years. So VISUS is in the middle between data mining and really detailed investigation and designs. It allows that visual inspections that will be done by trained surveyors will be implemented in order to develop kind of a triage for planning. It will really do fast assessments that will provide us the necessary decision-making information in terms of the safety weakness that we can find on that schools, on the interventions that are needed for that specific schools, and the budget allocation that we will require in order to secure the safety of that school, and with all of the different elements and information that will support decision-making processes and will define the intervention of different strategies. So this is where we locate VISUS in the whole level of knowledge, and we believe that this that has been proved and that has been tested and peer-reviewed by more than 35 global, well-recognized institutions is a good way to go forward in order to advance and has a clear picture about the situation of the schools in a really short period. So, how this worked in Zimbabwe? So we had the preparation of the steering committee. So this is the UNESCO headquarters that has been working with the UNESCO chair in Udine. This has been working on the methodology itself, but then this methodology needs to be adapted to the local context of the Chimanimani province. So to this end, we counted with the support of the Minister of Education, of course, as a main partner for this implementation, but as well as the colleagues of the University of Zimbabwe that allow us to collect the necessary information to adapt the methodology to the typology of buildings that we want to find, but as well to the typology to the risk profile of the areas that we're going to visit. This in order to understand better how those typologies will react to the different hazards that we will be finding in that specific area. We also counted with the support of UNOPS, who provide us also hazard information and building typology information, as well as cost information about how much it will cost to build a new school, how much it costs to build a classroom, what are the kind of typologies, materials that we normally use in those specific areas that will be visited. And similar, we have the support of two universities, one in the University Eduardo Mondlane in Mozambique, where we have implemented VISUS for the first time in Africa, that came to provide, to bring some hands-on training colleagues from the University of Zimbabwe, but as well schools. Similarly, from the University of El Salvador, that came to help us in the training, but also in the inspection itself. So then, with all of these materials that we have, with all of the information, we adapt the methodology to be answering the needs of the Chimanimani process. We develop a really short but fast training with the colleagues of the University of Zimbabwe, so professors of students that you're gonna meet later on, and also with colleagues of UNOPS that were with us in the implementation of this. We developed the survey using IT solutions like tablets, where we have a mobile application that allow us to collect this data. And with this survey supporting tool, we collect all of this data that normally is developed in graphical language in order to try to understand what was the situation there. Based on that, on the information that we were collected, all of this information was sent to our colleagues in the University of Udine in order for them to process with the algorithms all of these different elements that we have been collected in order to determine the outcomes that will be presented shortly by Professor Petra Malizan. So all of this has been implemented in a pilot base. If we decided to scale up, of course, all of these elements will be developed at the Ministry of Education of Zimbabwe, and as well with the other partners at the national level, in order that when we scale up, all of these informations can be directly sent to the Ministry of Education and produce the necessary reports with the support, of course, of UNESCO and the UNESCO chair in the University of Udine. So we have visited 15 schools, as Dr. Kuhn has mentioned, in the province of Chimanimani. So this were the area that we have visited for a period of a week. This is the program that we have during that days on which when we have the official launch, and I have the opportunity to be there in Harare with you. We have technical session of VISUS with the surveyor teams. Then we travel to Chimanimani and Chipinge districts. Every day we have 4 schools or even 5 schools to be assessed. And then in the last day, we went back to Harare in order to finalize our mission. Just before giving the floor to my colleague, Dr. Patrick Madison, I think that one of the areas that it is important to understand here is that all of this information will need to fit in a national strategy for of the education sector that needs to coordinate with other sectors in order to secure that all of these centers, all of these schools will have water and sanitation, will have a good access to water, a good access to electricity, a good access to roads, and that we can secure that the school safety is not only an issue of the education sector, but it's an issue of different colleagues of different ministries working together to secure a school safety at the national level. And with this, I would like to finish my presentation and to thank the team that was with us from UNOPS, from the Minister of Education, from the University of Zimbabwe, and that allow us to present today the outcomes of this implementation of VISUS in Zimbabwe. So thank you for your attention. Hui, back to you.
Thank you so much, Shaya, for your presentation. It delivered a very systemic introduction of the VISUS methodology, and importantly, how it was accommodated for local context in Zimbabwe and also in Chimanimani. So here now, let's welcome Dr. Patrick Madison to present the results from the VISUS assessments in Chimanimani District. Dr. Madison is a researcher at UNESCO Chair on Intersectoral Safety for Disaster Risk Reduction and Resilience from the Spring Lab at the University of Udine, Italy, where she achieved... Sorry? Yeah. So, yeah, please, you have the floor.
Yeah, sorry for the interrupting. Thank you very much for your presentation. Now I try to share my screen. Can you see my screen, my presentation?
Yes.
Oh, thank you very much. And thank you. It's a very large pleasure to be here today. I want to share with you my presentation, starting with the outline of it. And in the first part, we show you in a generic way the outcomes of the VISUS methodology that was summarized by Dr. Torres. So in the next part, I can show you how the results of the VISUS methodology are used to create useful statistics on the results for decision-making support. Then the analysis of the outcomes also allows to identify the presence of recurrent problems or concerns, which are illustrated in the last part of the presentation, together with suggesting recommendations to fix these problems. As previously described by Dr. Torres, VISUS assesses the school physical environment, therefore the location, the school year where the children go and play, and the buildings. And in the VISUS methodology, we distinguish the buildings between main and ancillary buildings, where the main buildings host the main activities of the schools, and ancillary buildings host the other services. As in the pictures, you can see some example of main and ancillary buildings identified during the project in the Chimanimani District. During this project, we assessed 15 schools, and this can be considered as a low number of schools having a limited representativity of the situation if we consider it with respect to the entire country. Nevertheless, in these 15 schools, there are overall 2,057 buildings, with 134 main buildings and 123 ancillary buildings. So let's say that in Ming, there are about 17 buildings for each school complex. Therefore, each school complex has a very large number of learning facilities. This is a very important issue to keep in mind while looking at the results. Concerning the general results of the VISUS methodology, in this slide, I want to summarize the graphical indicators provided by the methodology. First of all, I want to show you that the outcomes are divided in three groups, three main groups. The first concerns the safety situation. Where we provide the indicators concerning the identification of where the problems are in terms of location, schoolyard, main or ancillary building. And for each of these locations, the outcomes are provided through a three-level judgment expressed with the warning levels, where warning level 0, the green warning level, indicates that no concerns as being highlighted. Level 1, the orange indicator, refers to the potential presence of difficult situation, and the level 2, the red icon, refers to the presence of situation with potential severe consequences for personal safety. In the VISUS, there is another indicator that is the VISUS warning rose that was somehow presented by Dr. Torres while he was showing all the dimensions that are assessed by the VISUS methodology. So the location, the structural global, the structural local, non-structural and functionality dimensions aspects. For each of these aspects, we have the judgment provided through the needles that refer to the problems that are in the school. A summary of these outcomes is provided through an overall multi-hazard safety judgment that in the VISUS methodology is provided through safety stars that we call safety multi-hazard stars, since they refer to all the hazards assessed by the methodology. Each of these indicators that I illustrated to you is an indicator that is assigned both for each hazard assessed by the methodology and for the multi-hazard situation, therefore considering all the hazards. A second group of indicators is the safety upgrading needs, in which the indicator suggests both how to intervene on the schools in terms of a generic action and how much this will indicatively cost in terms of requirement for budget allocation. Finally, indicators on status provide a sort of quality judgment, for example, concerning accessibility, water and sanitation, maintenance, equipment, and we have recently also added the COVID manageability concerning the physical environment of the school. All this information is information for decision makers for supporting the definition of safety upgrading strategies. This information, together with the information acquired during the surveys, so the survey data, the photos, and all the information collected during the project, are stored in the VISUS database that could be simply linked to the education management information system of the country, so providing a lot of information for decision making. The VISUS data are also used to create, as Dr. Torres said, individual and collective reports on school, but also web maps and statistics on the situation. In the following, I will illustrate you the results we obtained for the school in the Chimanimani District. Here you can see a screenshot of the online map with the indication of the position of each school. The marker in each point reflects the number of multi-hazard safety stars assigned to the school complex. As you can see, there are only schools with 1 or 2 stars because this assignment reflects the worst case assigned for all the learning facilities in the physical environment for all the hazards, and it reflects the worst case in each school complex. By clicking on each point, however, a pop-up menu in this web GIS opens, and it provides more detailed information on the school, and also the possibility to click, visualize, and download the individual report for each school. So to have a very detailed information on each, on the results for each school complex. All the outcomes of VISUS are analyzed and summarized through pie charts or histograms, which are illustrated and commented in detail in the collective report. This slide shows only some statistics extracted from this collective report. And in this slide, I consider the number of multi-hazard stars that combine the results obtained for ordinary use, fire, flood, wind hazards, considering the worst case as previously mentioned. So the pie chart in the top left part of the slides show that 10 school complexes have one multi-hazard safety star only. That means, considering the meaning of the VISUS safety stars, that in this school complex, there is at least one facility. I remember that in Maine, there are 17 facilities for each school complex. So there is at least one with a situation in which the structural stability of the facility is not guaranteed concerning at least one of the hazards assessed. The other 5 schools that have 2 stars refer to schools in which, considering the meaning of the 2-star in VISUS methodology, at least one facility there could occur a situation causing potential severe consequences for personal safety, so a warning level 2 along the needle. However, in this pie chart, the outcomes, as I told you, are aggregated for the school complex, but the situation strongly changes if we consider the multi-hazard safety outcomes for each of the 257 buildings. So in the pie chart, in the bottom part of the slide. Here, you can see that the majority of the buildings have 3 or more stars. That means that at least a life safety performance, a safeguard personnel is reached by that learning facilities. In the top right part of the slide, you can see the pie charts showing the number of persons in schools with 1 or 2 stars and the STEAM required budget allocation for upgrading the safety of the school complexes. Looking in detail to the outcomes, I'll show you here the statistic distribution of the multi-hazard warning levels for each safety issues. Referring to the VISUS safety, to the VISUS road. The green bar represents the amount of buildings with warning level 0 for each safety issue, the orange warning level 1, and the red warning level 2. Concerning the location site, it is possible to see that 61% of schools have a warning level 1. This outcome is due to the fact that many school buildings are in areas where the ground can be scoured by flood water or rain. These aspects also generate cracks in the building walls, and this is reflected in the evaluation of the structural global aspects. Then, considering the structural global envelope, local envelope safety issues, it is possible to see that there is a significant amount of severe concerns, the red bars, and a detailed analysis of the data show that this is due to safety issues caused by roof structures that are poorly connected to the building walls. Concerning non-structural content, these are generally due to, the bars are generally due to potential falls of persons due to tripping, bumps, or fall of unstable objects. Finally, concerning functionality, the safety issues that the 90% of orange bar is in most schools linked to the fact that there are no pre-identified safe zones, and in some cases the egress from school building could be difficult or even impossible in case of an hazardous event. In the following, I will illustrate you the identified recurrent problems which have been also pointed out by the 3 VISUS experts who did the surveys. So looking at the location of the schools, it is possible to see that most of the situations that caused the orange bar were related to the presence of site conditions with potential ground scouring. Many schools are located in areas where the ground can be scoured by flood water or by rain. This is also facilitated by the slope of the school site. In the picture, you can see some images from the surveys. But potential solutions to reduce and control these issues require the intervention of the upstream area of the school with the hydraulic protection works that control the flow of the water, or intervention in the school site with the creation of terraces and systems to manage the water flow in the schoolyard. And some good examples were already identified in some schools in the Chimanimani district. The high erodibility of the soil in many school sites causes also the scour of the ground around the building foundation. In addition, school buildings are characterized by superficial foundations, as in many cases it is possible to observe exposed foundation and consequently cracks in the walls. Additional problems are caused by the use of erodible materials in the foundations that in some cases are strongly weakened. Most of buildings in the area have a reinforced masonry structure. In this typology of buildings, small cracks are easily developed. However, the settlement on foundations creates an enlargement of these cracks and a damage increase in the structure, as you can see from the pictures in this slide. Considering the site conditions and erosion effects, the superficial foundations that are not protected from scouring are not a good solution for the buildings. So the recommendations are to protect the existing foundations from scouring, as indicated in the sketches of Professor Peña, or to build a new structure, for example, with deep foundations. Concerning the structural local safety issues, in many buildings, the roof is poorly connected to the walls, and this could cause a potential roof uplift in case of very strong wind speed, which already occurred in the area during the Idai cyclone. Similarly, also the roof covering is often poorly connected to the roof structure, causing potential detachment of the covering sheets. In addition, in some cases, the quality of the roof material is very poor, with some very bad cases in which also severe damage already exists in the roof structure. So the potential solutions to the problems consist in improving the connection between roof and walls that could be done with various engineering solutions. And then there is a need to check the quality of the connection of the roof covering to the structure and ensure that strong winds cannot uplift the covering sheets. Finally, for the poor quality or a strongly damaged roof, it is necessary to reinforce the entire structure or even if necessary, substitute the structure. Okay. Concerning non-structural elements and functionality, we identified many different typologies of problems concerning mainly the lack of maintenance with the presence of broken glasses or broken roof sheets that could fall and hit the children. Moreover, in some schools, there is a presence of asbestos sheets in the roof that should be substituted, especially when they show cracks. In some schools, the roof structure is used to store materials, and this could be dangerous for persons sitting below. Moreover, as you can see in the picture, there is in some schools the presence of damage in the floor coating with holes in the classrooms. Also, unprotected windows opening on pathway could be potential threats for children walking on this pathway. So I want to conclude with some general consideration derived from the above data, which lead to the main recommendation to define a school safety upgrading action plan, starting from the VISUS assessment outcomes. In addition, the VISUS expert surveyors interviewed the school personnel, the teachers, with questions that go beyond the technical aspects that concern the VISUS methodology. This additional suggestion can be summarized as follows. First, there is a necessity to promote a community-based safe school construction, acknowledging that communities best know their context capabilities, and considering that this also fosters a sense of ownership concerning the school. Then The accessibility to schools in Chimanimani province is challenging, and it's important to improve the accessibility both for students and also for emergency services. Third, we highlight the importance to improve the living condition of the teachers who live in the same school they teach, and the assessment showed that these schools have a very poor conditions. These buildings have a very poor condition. A final general suggestion is to improve the building code and ensure compliance while building new schools or while intervening on the existing ones. Moreover, it is also necessary to ensure that the right to education is maintained all the time, thus limiting the use of schools as a shelter that is common in the province. Thank you for your attention.
Thank you so much, Patrick, for your explanation on the results in Chimanimani with very solid recommendations. It was quite impressive. And I trust people now have a better understanding on the VISUS and its applications. So now I think it's also very interesting to see the scaling up of the VISUS applications to a higher level, which is also quite important. So let's welcome Prof. Stefano Grimas to discuss about the VISUS for defining safety upgrading strategies at territorial level. So Prof. Grimas is the chairholder of the UNESCO Chair on Intersectoral Safety for Disaster Risk Reduction and Resilience at the University of Udine in Italy. He is also the director of Safety and Protection Intersectoral Laboratory, which is the Spring Lab in the same university. He carries out the research on safety and emergency management with a holistic and intersectoral approach for developing multi-hazard safety assessment and decision-making support tools. Now you have the floor, Prof.
Thank you very much. Just a moment that I try to share the presentation. Can you see the presentation?
Yes.
Thank you. Good morning to all of you. Now I want to show briefly how we can use the result of the VISUS assessment for the definition of an action plan for improve the situation of safety of the school. The goal is to define the strategy. You know that a strategy permits to pass from a current situation to a target situation, taking account also the boundary condition in terms of resources or laws that we have to fit. But what is interesting is to define the right way to pass from the current situation to the target situation. The target situation is something that have to be defined from the decision makers. And in this way, the VISUS outcomes that are presented before from the Dr. Malizan and also Jair Torres permit to have what we call the starting point in terms of safety situation, intervention needs, budget required, and status of the actual situation of the schools, but in the same time, it's necessary to define the goal that we want to reach, and this permits to implement what we call the action plan in terms of interventions, priorities, and especially finalization of the single intervention. If we follow the criteria of the optimization, that means that we maximize the goals reached. The first step is the definition of the goals, but we need to start from the current situation. So with the outcomes of the VISUS, we can define different type of goals from which then depend the strategy. For instance, we can define to improve the safety of all the school. For instance, defining the level of staff that we want to reach for all the schools that we have assessed. We can improve a single response to a single hazard or a multi-hazard. we can define a strategy for maximize the number of schools that at the end of the intervention are safe, or we can maximize the number of students that after the action plan is implemented, we obtain. This permits to define different paths of intervention that could be defined taking account different criteria and strategy. For instance, with reference to the case of Zimbabwe pilot project, this is the results in which we classify the stars of the single school assessed, but in the same time, we can define also the budget allocation required to resolve the problem, to upgrade the safety situation. And this permits to define different possible strategies. Just like an example, the first a first strategy could be to resolve the problem in firstly in the schools that have the worst condition, and subsequently take in account also the number of occupants that are internally of the single school. Or we can define a strategy that takes in account the cost, the cost that required in terms of dollars invested per person. All this information are internally of the database of VISUS, so it's possible to define a different strategy, taking account the different goals and the different criteria that decision makers decide in a political way for managing the problem at territorial level. Another aspect that is permitted by the outcomes of the VISUS assessments is the taking account another aspect that is the convenience to choose one or another intervention for resolve the problem. For instance, if we consider a temporary building, not all the building assessed are permanent building, we can reach a safe situation maintaining the status of the building, or we can decide to improve the situation obtaining another standard of status. This permits to the decision maker to define if it's convenient repair or rebuild with a permanent building. This symbol that permit to define the upgrading requirement class permit to decision maker to evaluate if it's convenient in a cost effectiveness way to intervene or not, considering that if the cost for upgrade is more or less the same of reconstruction, maybe it's better to proceed with the reconstruction. Otherwise, is convenient in an economical point of view to proceed with the repair, the retrofitting. Obviously, if in the country there are some constraints related to the cultural heritage aspects, we can proceed also if it's not economical convenient and put this like a priority. But what is important is that in the decision we have the safety aspects on one side, but the other side also the status that in terms of facilities, the performance, the services that permit to have internally of the building. So these two aspects are very important. The other aspect that permit the VISUS approach is to proceed, if necessary, with sectorial action. For instance, if there is an availability of funding for only for non-structural intervention, because there is a law that found only non-structural intervention, considering the results, the outcome of the VISUS assessment, we can make this observation. If we consider the situation 1, in which the location is okay, the structural global is okay, and the structural local aspect are okay, this means that we have not needles in the rows for this aspect. This means that this is very good proceed with an intervention in terms of improvement also of the non-structural elements. Otherwise, if you are in a situation like the 2 and 3, in which we have serious problems in the location or in the structural aspect, have not sense invest money in order to improve the non-structural intervention without before improve also the location and structural aspect. Otherwise, we use the money in a wrong way. This permits to obtain a sort of balancing between the money that we use in the preliminary assessment and what we can use for the effective intervention of the building for the safety improvement. So taking account the results of the VISUS, we can define the action plan with the criteria that I mentioned before in terms of relocation, reconstruction, retrofitting, but also we can select directly the schools in which the problem could be resolved by self-management internally by the school, especially for the functional aspect. But in the same time, we can proceed with the criteria that I've already explained before of safety, but also by typology, by level of status, or for different areas in the country. As Dr. Malizan explained also, if in the pilot project we assess only 15 schools, that is a low number of schools, we found recurring problems related especially for the schoolyard. So this permits also in terms of planning, action planning, to define some common solution in order to also to optimize the use of resources. This permits to have a picture, an overview of the global situation of the schools. VISUS can be also used as a sort of control tool, because we can have the assessment of the current situation. We define the action plan, we proceed with the intervention in order to remove the criticalities that we assess during the evaluation. And the right goal is that after the implementation of the intervention, if we reassess the school, the best situation is that all the needles of the rows of VISUS rows are deleted, are removed. This is a possible control tool of the final result of the intervention. I would like to remark some aspects about the VISUS, like a decision-making support tool, because as you see, VISUS methodology support the local authorities in defining rational strategies, considering specific criteria and political choice. It's not the methodology itself that define the priorities, but permit to the decision maker to have all the elements that from which they can start with their criteria and their political choice to define the action plan. So this is very important, because this permits to take in account also of other aspects that in the political choice are very important in the different countries. Second aspect that I want to stress is that VISUS is a science-based approach and has been implemented and conceived in order to obtain a tool for support political choice, in order to avoid to substitute the choice and permit to the decision maker to take their decision on the data of the database of the VISUS assessment. Last but not least, VISUS is a very important tool for knowledge transfer in terms of capacity building, because during the training, all the knowledge for the assessment is transferred to the local technician and also new generation, because we usually like to work involving the students of the university, and this permits to improve also the capacity in the country to self-manage the assessment in their country. Last, I would like to finish my presentation with the final wishes, taking account the results and this experience in the pilot project in Zimbabwe. Obviously is a very little pilot project, but the results permit to say that could be very important if there is the political commitment of the government to assess the schools in a more large territorial level. It's possible to enlarge this experience in another parts of the country. What is important from our point of view is to continue to the engagement of the University of Zimbabwe, because it's very important that the methodology permit to create local capacities to manage and use the methodology and use the University of Zimbabwe, taking account this experience as a main scientific partner for implementation national level. Obviously, this requires also to, if you decide to go in this direction, to integrate other universities of the country for replicating the training and increasing the capacity of self-managing the school safety assessment at national level. Like a last consideration, we can say that we are ready and proud, very proud to support you in this implementation that is functional, as Dr. Jair mentioned at the beginning of the presentation, his presentation, to achieve the goals of the UN Agenda 2030. Thank you very much.
Thank you so much, Iser, Prof. Stefano. The presentation is quite valuable, especially with the detailed demonstration on providing the inclusive and also complete solutions with the available resources. I think people would like to understand it more further after the presentation. So now we may hear some voices from the local experts in Zimbabwe. As mentioned, a group of local experts from the University of Zimbabwe also joined the VISUS assessments in Chimanimani. They are Webster Gumindoga, Prosper Marindiko, Forgiveness Chaka, and Obe Mugoderi. And today, Mr. Webster Gumindoga and engineer Prosper Marindiko will be representing the team to share their experience and lessons learned from the VISUS. So Mr. Webster Gumindoga is the lecturer and the researcher at the University of the Department of Construction and Civil Engineering. His research work involves the application of GIS and Earth observation techniques in hydrology, water resources management, and disaster risk assessment. He was the local experts team leader in the VISUS field trip in Chimanimani, Zimbabwe. So Mr. Gumindoga has nearly 50 publications in the areas of GIS and remote sensing applications in climate change modeling, flood and landslide risk assessment, as well as the civil and water engineering. And engineer Prosper Marindiko is a civil and structural engineer with more than 10 years hands-on experience in academics and in the design office. He is mainly involved in the steel work and reinforced concrete design work. He has been a team leader of a number of major national projects, including the infrastructure theme of Tukwi Mukosi Master Plan. Mashingo proposed the new Harare Master Plan. He was one of the local civil engineers in the VISUS pilot project in Chimanimani. So now you have the floor. Thank you.
Okay. Do you mind sharing our screen? Electricity just went from this side, so I'm now using my mobile. So do you mind sharing our presentation from that end?
No problem. So our IT colleague, maybe Magnani, you can help.
Okay, so whilst the IT guys are sharing the screen, I just want to thank you so much for giving us the opportunity to participate as the local experts. And so I'll just go to the slide number 2, where I just give an overview to say that UNESCO ROSA organized the pilot launch of VISUS methodology in Chimanimani with the aim of later scaling up across Zimbabwe. And us as the local experts, we also engaged to build local capacity in implementing the VISUS methodology. So we understudied how to conduct the multi-hazard analysis and determine where needed, something needed to be retrofitted, to be rebuilt, and also to be repaired. And as a pre-field experience, we also conducted by the VISUS experts to provide to gather some information in relation to the maps, the Google Maps, for example, rainfall, geological maps, terrain, before we went to the fields to provide the local building codes, the construction material information, COVID-19 guidelines, school location, identification, and many other important information that was needed before the field. And so we also attended the training workshop in October at the UNESCO offices together with the experts when they came. And also we were involved in many other things to do with the planning. And also the next slide on the on-field experience, we're actually involved in the data capture on the VISUS application with some of the information that has already been presented by the experts, the Torres and the other team members. For example, information about the school and potential hazards. We would also walk around the schools. We got to have that experience to inspect the schools, to walk around the schools, also to do internal inspection, to select the best pictures, to take the best pictures and be able to link with the software. So that's part of the on-field experience that we managed to get. And on the next slide, the post-field experience, as you can see from those pictures showing the interior and exterior damage at the Zingire Primary School there in Chimanimani. We learned how to do the information verification, to do the school layout, map updates, to clean the data, also to upload the data to the server, and also the data processing. That's part of the experience that I can say we also obtained. On the next slide, this has been presented, but just to also to give a summary from our experience as the local experts, we learned, or we saw that most of the schools, they're built to the British building codes with mainly masonry code, but not very much strict adherence. We see that certain schools were built to those codes, and also to realize that certain schools are not built to those codes. But even within the same school, some buildings are built to certain codes, but some are not. So that variation we saw amongst the 15 schools that we visited, and also realized that the BS timber building codes for other buildings were also something that we could see. Timber structures also. But most of the schools, as you also see from the previous presentations, they are located in hazard-prone areas. It could be floods, landslides, where there are earth tremors, and also the slope. In most of the schools, we saw that the slope It's too steep in most of the schools actually, such that if there is any hazard happening, most of these schools would be destroyed, putting the risk of teachers and the communities surrounding, and also the kids. Overpopulated classes, that's something that we also saw having an implication in terms of COVID-19. Some of the schools had inadequate space for expansion. Some are just very too close to a mountain or too close to rivers. That's something that we saw. Maybe if there's future expansion, we are recommending to introduce vertical typologies. And then on the next slide, what is the applicability of VISUS in Chimanimani? We say that these two very, very important, as we saw, and also as has been presented, also from the responses that we saw from the headmasters, from the teachers, from the communities. It's a very important tool that will also help in risk reduction and also to standardize school risk assessment. I know in the past there have been a lot of efforts to do schools risk assessment, but the VISUS tends to standardize things, and I'll say that it's a very important methodology. And also it helps us to see the level of safety assessment that we also saw from the results that have been presented, and also where to prioritize resources. If resources are going to be allocated, VISUS comes in as a hand to say, let's prioritize resources in this area or in this school or in this community. But also VISUS provides a scientific base for retrofitting, repair and rebuilding decisions. So without just going to a school and saying you need A, B, C, D, E, the outputs of the VISUS, I would say that they are much more applicable in terms of making decisions by the ministry, the relevant ministries, and the communities. Then efficiency and cost effectiveness is very, very important because it provides, since it's an application-based, it's very efficient and also introduces effectiveness and also time management and also cost reduction. On the next slide, so what are some of the things that we would recommend for improvement in the schools? Some have been mentioned, but allow us also from our own assessment that we did, that there's need to improve accessibility of these schools. Most of them are not accessible. Need for enforcement of adherence to building standards so that, you know, a school cannot just wake up and say, we want to build this type of structure. Because if you see in some of the structures, they can be easily be distracted or be destroyed by the hazards that will be coming. It can be the tremors, can be the floods, can be landslides. In fact, this area is very prone to many hydrometeorological hazards. Need to move from pit latrines to nowadays to water, to flowing water in the toilets. That's something that we also saw. Provision of waste receptacles, landscaping of school perimeters, increase window size to maximize on daylighting, adoption of louvered windows to avoid learners colliding with window frames. I saw one of the experts presented on that. Adoption of standard timber construction as it is abandoned. So we saw that there's a lot of timber, but very few structures uses timber actually. The next slide. So we, us as academics, also as the local experts, but academics, we saw that, okay, VISUS is very important. What are the project offshoots that we can have from the VISUS? We can have many of the projects. We've actually started from our students, BSc and postgraduates, for them to start projects related to the VISUS. For example, multi-hazard mapping in the Eastern Highlands. As you can see, there's a map there on the left side to try to do multi-hazard assessment. This is a landslide map. And many other projects as shown on the screen on tremors, on winds, roofing stability, story buildings, trusses, sustainable low-cost timber structure. So I can say that we already have our BSc and our postgraduate students starting to work in the Eastern Highlands using some of the outputs that we've already obtained and the experiences from the VISUS project, right? For example, we already have from that picture, the lower classroom there. We already have a student just trying to recommend the best roofing. That school roof was wiped away by the winds. So we're saying what type of roofing will be appropriate for this. Next slide. Forgive me. So on the next slide, we are saying, what is the upscaling approach in Zimbabwe? How can we have this methodology being upscaled in Zimbabwe? We are saying, let's update the schools location database. We realize that some schools are not in the databases, in the spatial databases. Let's utilize OpenStreetMap and Google Earth. And let's be able to utilize even the technologies of offline GPS to coordinate in the field when you are upscaling for Zimbabwe. Also using other mobile data collection kits such as ODK to integrate them with the VISUS methodology. More institutions being involved, for example, the ZINWA, the Med Department, the Civil Protection Unit, and produce as many hazard maps as possible. But also to have the universities beginning to research on these hazards for like the projects that we've already started from the university. But also to tell you that they use a team. As a team that has been trained, I can now say that we are now able also to train others on the VISUS methodology. Will such be an opportunity to be availed? I can say that we now have obtained the skills as we have been taught by the experts. So, my last slide. So, excuse me, I've just choked, but let me just finish. My last slide is this one. Where are the districts that we can focus on? Would you want to implement this methodology? So we sat down as a team and saw that, okay, these are the typical districts. For example, in each of the provinces of Zimbabwe, we selected one district, at least one district that we can focus on. And we've even mentioned what type of hazard is there. For example, you can see in Masvingo and Mwenezi, there's a lot of hailstorms, and lightning and wildfires. For example, in Kwekwe districts, you know that the issue of the mining activities, open peace because of mining. In Cholocho, in Matebele North, there's a floods and sandstorms, etc. So we've just been able to say, if this methodology is going to be implemented in the whole of the rest of the country, these are some of the issues that we already know of in the country and the districts that we can focus on. And by that, ladies and gentlemen, I can say that it was really a good time to be in the field with the experts on the last slide. With the experts, want to appreciate the skills that they put in us and the confidence that they also saw that they've bestowed on us as the local experts. I say, Maita, Tatenda, Siyabonga. Thank you.
You should have said Mashuma if you were in Chimanimani.
Mashuma, thank you.
Your mic is on mute, Queen.
I'm so sorry. Yeah, thank you so much, Webster and Prosper. The experience shared as well as the lessons shared are quite interesting and practical, especially for the critical areas which give us an inspiration on the way forward. So now we will have the question and the answer session for discussion. If anyone has questions, please just raise up your hand, and once we see the sign, we will let you speak. Is there anyone? It seems that the audience are still trying to digest the fruitful results from the field, as well as thinking about what's the way forward. Okay, I saw a question from Mr. Nansen. Yes, please come in.
Yes, Dr. Hu, how are you? I want to start by thanking the professor, the two doctors, and our local contingent, as represented by Comrade Gumindoga. Thank you very much for this eye-opening if we were to go to the 15 schools which we were focusing on, do we see anything, or you were just extracting some information and you went away? Is there anything that we have done for the schools yet? Or it was the effective finding mission first, then action later? That's my question, madam. Thank you.
Thank you. Jaya, do you want to come in to answer?
Yeah, but could you repeat the question? Because I didn't. It was my internet was falling down.
Yeah, my internet was also quite unstable just now, but I think the question is about, do you have any solid recommendation on the way forward for the 15 schools assessed in Chimanimani with very detailed, how the government can pay attention to it. If I didn't catch the wrong point, because I was also unstable just now.
Please go ahead, Mr. Nkomo.
Thank you very much. I wanted to say Dr. Hu is a very good moderator. She has said exactly what I said in a different manner. But in addition to my question again, the 15 schools, looking at some of the hazards that you have just highlighted, we cannot wait until action is taken later. Are they now fully conscious of the situation they also find themselves in? So that if they are not fully aware, action should now be taken, notwithstanding that we need to go through all the bureaucratic channels whilst a group of people are a serious hazard.
Okay, thank you, Mr. Nkomo. Yeah, actually, well, most of the recommendations that were specifically for those 15 schools were presented by Dr. Madison today. We believe that those recommendations are being taken by our colleagues in UNOPS, who are actually working on the improvement of those 15 schools. So I guess that this is something that maybe our colleagues from UNOPS can comment when they have the time for their presentation. I think that the most important is to see that in those specific areas of Chimanimani, those schools really host a lot of students and a lot of communities. They are very important. They play a very important role within the community and within the education sector there. There are schools that are really huge in quantity of students that go there. We saw, for instance, that many of these schools were located in a very in a good areas that may need sometimes of site works in order to secure the site. But in general, most of the issues that we have found there were related to functional aspects and to non-structural aspects that are more related to the lack of maintenance or related to these aspects that are not related directly with the structure itself, but are more related with safety issues that the structure can cause to the kids. So those recommendations, as Dr. Malisan has mentioned it, are those that we have been giving to the Minister of Education and to the colleagues of UNOPS, and we really hope that actions could be taken in those 15 schools, while a larger program for assessing a big quantity of schools could be done in the coming months. Over to you.
Thank you so much, Jaya. Yeah, I think today the webinar might be, time limited to discuss in depth about the detailed work plan and the way forward. But actually, after this webinar and from next year at the beginning of the year, we will have a very detailed, in-depth discussion, gathering the experts who attended the VISUS field assessments in Chimanimani, as well as the technical engineer in UNOPS and their program specialist, and of course involving UNESCO ROSA, and also the relevant ministry like the Ministry of Primary and Primary and Secondary Education, and the DCP are likely to be invited to that meeting for further practical steps for the following work. Thank you. And I noticed that there's another question from Steve Collins from US Ed to ask about, does UNOPS have budget to take the recommendations forward? So for this thing, I think, I don't know whether the representative from UNOPS today can answer the question, because they are the representative from UNOPS, but they are not tackling the work area related to the budgeting as well as the detailed project. So I think we will have a very clear answer later next year at the beginning, and we will update you when available. Thank you. Is there any other questions? I noticed that Mr. Nathan Nkomo still have the hands on. Is it a new hand or old hand?
It's a legacy hand, Dr. Hui. It's a legacy hand. Let me take it off.
Okay, thank you so much. Is there any other questions? Okay. Seems people are still digesting, and maybe they are waiting for further updates at a later stage next year. Okay, if there's no more questions, so maybe we move on to the next session. Let's count 5 seconds. If there's no more question. 5, 4, 3, 2, 1. Okay, let's move on to the next part. So now let's have the last part of the webinar, which is mainly about the remarks. So first, let's welcome Mr. Absalom Chinuna, who is the Acting Deputy Director for ICT, E-Learning and Technical Services from the Ministry of Primary and Secondary Education. Mr. Chinuna, you now have the floor. Thank you.
Thank you very much, esteemed moderator and esteemed presenters. My remarks are going to center on the importance of school safety assessment and the ministry initiatives in disaster risk reduction. The Ministry of Primary and Secondary Education attaches great importance to the mitigation of disasters in schools.
Sorry, Mr.
This is in a presentation on the outcomes of visual inspections.
Yeah, sorry.
Hello.
I think we forgot to share the slides. So if you cannot share from your side, maybe my colleague McNally can help you to share the slides that you prepared.
Okay.
Okay.
Just
so McNally, can you help?
Oh yes. So can we go on to the next slide? Hello, are you hearing me?
Yes, Magdalene is trying to share the new slides, so please wait for a minute. Thank you.
Thank you. Anything on the screen?
Not yet. Yeah.
Okay.
Now it's okay. So
fine.
Which slide are you focusing on? Yeah, please.
Right, that one. The ministry attaches great importance to the mitigation of disasters in schools. This webinar presentation on the outcomes of visual inspection for defending the safety upgrading strategies, VISUS, for the Chimanimani District through the Zimbabwe Idai Recovery Plan is highly appreciated. We highly appreciate this initiative. We note that the launch session to mark the beginning of the initiative on visas in Zimbabwe was held on Monday, 4 October 2021. Of importance is to note that the visas methodology is developed for the multi-hazard school assessment by UNESCO. Next slide. Next slide, please. The disaster that happened in Chimanimani as a result of Cyclone Idai was quite devastating to schools and the community at large. Through this VISUS methodology, we will be able to come up with policies that may effectively ensure reduction of risks in our schools, as this is based on scientific evidence. We also note that scaling up of the VISUS initiative to other districts in Zimbabwe is an appreciable disaster risk management to disasters such as droughts, floods, heavy winds, landslides, and earthquakes, although these earthquakes are a rare phenomenon in Zimbabwe. Disasters impact on children, youth, and the education system. UNESCO, through the Zimbabwe Idai Recovery Project, is taking steps to improve safety in educational infrastructure in Zimbabwe, Chimanimani and Chipinge, in particular, using VISUS methodology. I am pleased to note that VISUS facilitates risk assessment in school facilities, gatherings of fact-based practice information to help decision makers, identification of areas of concern and priority investments. We note with appreciation that 15 schools were assessed in respect of the following: site conditions, structural, local structural criticalities, non-structural components, functional aspects, and COVID-19 in the assessments as a way of improving the safety of the children. VISUS should be replicated in other districts prone to disasters. This is our wish. So what is Ministry of Primary and Secondary Education doing to mitigate disasters? So our ministry is ensuring functional fire extinguishers in schools, having disaster management committees in schools, doing awareness campaigns for disaster reduction, sinking of boreholes for students to have access to clean water, implementing school feeding programs to reduce hunger, encourage income generating activities. And another point that I had not put there is that as a ministry, we We've got inspectors who inspect infrastructure. In other words, any physical infrastructure that should be constructed in schools is to undergo inspection and approval. Otherwise, we are very grateful as a ministry. We are grateful for the disaster mitigation efforts offered under VISUS. I thank you most sincerely for your listening.
Thank you so much, Mr. Chinona. So now let's welcome Mr. Nanzen Nkomo to represent Department of Civil Protection to do the remarks. But from my understanding, Ms. Veronique Charumbira maybe will represent you to do the remarks, but you will provide the comments. So Ms. Veronique Charumbira is the Principal Administrative Officer for Response Operations. You have the floor, please. Veronica, are you here?
Thank you very much, Dr. Hu. Let me rescue the situation.
Okay, no problem.
Yes, sorry for that. I had delegated to Veronica because right now I'm under the weather, you know, with COVID-19, a lot is happening. So let me try and come up with some remarks. I want to start by thanking the presenters for their good presentations in the areas of school safety. And I am happy that the approach we have adopted, Madam Moderator, is very comprehensive in nature. As the Acting Chief Director for Civil Protection in Zimbabwe, yes, we've been trying to look after the safety and welfare of the 4.5, if not 4.6 million learners. But I think when you introduce this VISUS methodology to us, that's when we realized that there was a tool, and there's a tool which could actually standardize the manner in which we provide safety in all our schools. Given the plethora of players in the schools, there is government, there are local authorities, and now we are seeing quite a number of mushrooming private schools also emerging. So I'm sure with a tool which is scientific in nature being applied, we should then be able to deal with certain things which were taken, certain hazards which were taken for granted, that these ones we can always deal with them as we go, and I'm sure we can now deal with all those hazards. And the critical aspect which you have mentioned, which is one of lack of maintenance, it remains a serious issue in as far as the social amenities infrastructure in this country is concerned. Some schools have last seen maintenance in the past 15 or so years because of the prevailing economic situation. But we cannot continue exposing our learners to such a kind of hazard. There is need for improvement. Yes, for Chimanimani, issues of typology, which you have alluded to, are also very critical. The terrain, is it good to have a school where it is now? And I'm happy that as the local content as represented by Mr. Gumindoka, the issue of coordinates in any disaster situation, sometimes coordinates play a very critical role. So once all these schools are registered, we should then be able to come up with coordinates and be able to reach those schools in times of hazards. And when the professor was talking about scaling up the program to other schools, to me, I said it was a welcome development, because this scaling up to me means we are now proactive in preempting some of the inherent hazards within quite a number of schools in different areas. And a critical issue which both the two doctors highlighted, one of siting of the schools, is also very critical, and which was also highlighted by Mr. Gumindoka. You know, as we come up with these public investment plans, there are a lot of issues that we must take into consideration, given the three recommendations where you were now talking about relocation. I'm sure you witnessed one school where we lost 3 lives, which was relocated to about 80 kilometers from where it is now in Chimanimani. And all these issues must also be taken into consideration. We must also take into consideration the geophysical survey results which were done by ZINGSA. I know the University of Zimbabwe and ZINGSA are symbiotic twins. They always work hand in glove. I'm sure all those maps and other results were also taken into consideration as you were looking at the 15 schools. Remember, it was in Chimanimani during Cyclone Idai, where initially the first 30 schools were closed before the school had even come to an end. So all those issues, we have lost lives amongst our school-going children and our teachers. So I'm sure this important tool, we are also embracing it in our DRR strategies, especially during our recovery and resilience building efforts. I wish the University of Zimbabwe can quickly replicate as what Mr. Gumindoka was saying, so that we also benefit, especially our decentralized structures. You have talked about the system being able to equip our local authorities. This is a critical component of our governance structures in Zimbabwe. A local authority, by its nature, is the third tier of government, which must be fully capacitated by being exposed to some of the tools which we have mentioned here, especially the VISUS. Because as you were presenting, showing us the roofing materials which were used, you could actually see that there were some structural challenges associated with the building. And this has far-reaching implications in terms of the designs of some of our schools, which now require a new way of doing things. And next time when you will be presenting Dr. Hui, I'll make sure the contractor of choice in government, which is public works, they are also fully represented, so that we start conscientizing them about the need to move away from the old stock type of designs. I know education, yes, you have inspectors, but most of your designs, they come from the Department of Public Works. That Department of Public Works must also now rebrand itself by coming up with new designs which speak to contemporary challenges. I am happy, Madam Moderator, that this scientific-based approach will assist in ensuring that the existing political will remain with us in addressing some of these challenges through standing cabinet committees, some which are ad hoc in nature, and until up to cabinet. We have clearly defined the structures. So science must continue convincing our policymakers that it is possible with science to address some of our contemporary challenges. But more importantly, Madam Chair, as I conclude, knowledge transfer I think is the last thing all people want to hear. Each time you go through an exercise, each time you go through a project, this is very critical in terms of sustainability and development of this country. Thank you very much that we couldn't share to come up with these few remarks after realizing that maybe Veronica Charumbira was facing some connectivity challenges. Thank you very much, Prof. Thank you very much, the doctors. Thank you very much, our local content, the University of Zimbabwe. And thank you very much, other fellow participants. Thank you very much.
Thank you so much, Mr. Nkomo, to chip in and also deliver such a very informative remarks. And also thank you so much for your recognition of the VISUS initiative that we are promoting in Zimbabwe. Also, as you mentioned, and also as Prof. Stefano mentioned, it is very important to utilize this kind of science-based methodology for school safety assessment, as well as to do the knowledge transfer. And we are all happy to see that the team from University of Zimbabwe already got the very central and the core technical skills from this methodology, and we all look forward to seeing the replication of this methodology into other districts in Zimbabwe. So I think definitely we will have further communication after this webinar, and we will formulate very solid action forward later. So now,
sorry, Doc. Yes. Sorry, Doc.
Yes.
There was one important point which I wanted to mention, that whilst the UZ guys are so happy that they can now cascade and replicate this VISUS methodology, one barrier to accessibility of such a critical service are the fees to be charged by our university guys. Let them be reasonable. We are ready for you anytime, any day of the week. Thank you very much to receive that kind of training. Thank you.
Thank you. Yeah.
Okay.
I think we can talk about it later on and really have a very detailed work plan. Thank you so much. So now let's welcome the last speaker from UNOPS, who is Mr. Andrew Ninjinha, for the monitoring and the evaluation for the UNOPS Community Infrastructure Project. And he may deliver the closing remarks representing UNOPS. So Andrew, you have the floor now. Hello, Andrew. We cannot hear you.
Okay, can you hear me now?
Yes, perfect.
Okay, thank you. Good afternoon, everybody, ladies and gentlemen, all protocols observed. We are very grateful for the great work that has been done by UNESCO and all of the partners. We would like to acknowledge all of the entire team that worked with UNESCO to complete the VISUS assessment. That includes the University of Zimbabwe, the University of Udine, the UNESCO team in Zimbabwe itself. There was also some critical support provided by the Ministry of Education, the consulting group, I think SAR Consulting, and the governments in Chimanimani and Manicaland. We would also like to acknowledge one critical partner who I'm not sure whether they represented, the World Bank, who are financing the ZIRP project. So ZIRP is a 4-year response conceived after Cyclone Idai in 2019, which intends to restore access to critical services such as education, healthcare, and also reconstruct infrastructure such as roads and clinics and schools that were damaged by the cyclone. It involves 9 UN agencies, of which UNESCO is joined last year to provide support with resilience assessments targeting community infrastructure such as schools in Chimanimani. With the completion of the VISUS assessment, we now have critical information that will be applied in the reconstruction of school infrastructure that was damaged after the cyclone. And we find infrastructure to be one of the most important aspects of resilience building, especially in the wake of Cyclone Idai, and also given the current context, the recognition that in future there is likely to be a chance that weather-related disasters will become more frequent, more intense, and building better infrastructure is one of the best ways that we can adapt to this future. Through partnership with UNESCO, we've been able to determine the flood and landslide risk map. We've been able to come up with flood and landslide risk mapping for Chimanimani and Chipinge, which will be important for planning carried out within ZRP, where UNOPS and other agencies are rebuilding damaged infrastructure, but also for the planning and the reconstruction carried out by the government in those areas to support the local communities. We also intend to apply the VISUS assessment in the rehabilitation of the schools damaged in Chimanimani. While this has been a long process in the preparation of the schools, in the preparation of the school designs and the procurement of the contractors, we're happy to announce that starting from January, we'll be able to start the school reconstruction in earnest. I know this is something that the government in Chimanimani, the government in Manicaland, and the Department for Civil Protection have been keen to see begin. And we'll be very happy to explain that this will now start in January. It will take place throughout most of next year, and by August, the school rehabilitation will have been completed. Now, in the context of the rehabilitation and reconstruction taking place, we have an opportunity to build back better and modernize school infrastructure. And the end goal here will be to bolster resilience within these schools and to improve the quality of facilities provided so that we can enhance the quality of education provided to children in Chimanimani. But we also envision a scenario where the practices applied in Chimanimani are applied in the practices we apply in Chimanimani are also extended to other districts in Zimbabwe where we are not working. The main principle behind building back better is to use best practices to increase the resilience of the infrastructure being provided, but also to improve the way in which infrastructure is developed in Zimbabwe. One of the things that we're looking at here is that we will enhance the use of an evidence-based infrastructure methodology. Now, we have to recognize that currently the government of Zimbabwe is already very keen to use all forms of evidence, all forms of information and data available in the construction of in the development of infrastructure. This is because as we worked on the designs and the infrastructure for the schools and the roads that we are reconstructing, we received a lot of critical support from the Meteorological Department, the Department of Civil Protection, and the Ministries of Health and Education and Transportation, with information and data that they had already collected for their own use, which has proved to be very vital for the rehabilitation work that is taking place. A second key step that takes place in building back better is we utilize global best practices in the development of infrastructure. Again, here, Zimbabwe has fantastic building codes that we've relied on. And simply what we've done is we've borrowed ideas from other countries where UNOPS has worked, neighboring countries such as South Africa. We've also worked with the latest British building codes, which is what Zimbabwe's own codes are founded on, to see what improvements, what enhancements can be made to the local designs, just to make sure that if there is another cyclone, which is likely to happen perhaps in the next 10 years, the schools, the roads that are rebuilt in Chimanimani and Chipinge are much more resilient to the damage that takes place, and the impact of the cyclone would be minimized. Lastly, through practices such as VISUS, through our cooperation with the government, through our coordination with different departments and stakeholders who are here locally, we are ensuring that local partners have access to the same knowledge, tools, and methodologies that are used by groups such as the World Bank, UNOPS, and UNESCO, and the consulting firms brought in to support us with this work, so that we ensure that we enhance the capacity and the expertise in these in the development of infrastructure. I believe the University of Zimbabwe and UNESCO mentioned that through the VISUS assessment, local teams are trained on the practices used to carry this out, and now they're capable of doing the same themselves. Similarly, we're hoping that the hazard maps that we share will provide local knowledge to the government that they can use in the development of infrastructure moving forward into the future. And just in the same way, the designs that UNOPS is preparing for the schools, the roads, and the clinics will be locally available for the government to use to enhance infrastructure in Chimanimani, where for the facilities that we were not able to extend to, and also beyond Chimanimani in all the other districts in Zimbabwe. So in the context of all of this, we're very grateful for the support that we've received from UNESCO. We would like to thank the government of Zimbabwe. Their assistance in all of this was very critical. The consulting group, SAR, their involvement was also very critical for the completion of this exercise, as well as the universities, the University of Udine, I hope I'm pronouncing that correctly, and the University of Zimbabwe. And we look forward to a future where the development of infrastructure in Zimbabwe continues to be based on an evidence-backed approach, which ensures that the best knowledge and information is available locally, enhancing the way infrastructure is produced so that there is better resilience, better adaptation to climate change, and a better understanding of what the end users' needs are in all of the facilities provided. Thank you.
Thank you so much, Andrew. It's very glad to see the reflection from your own view as well as the view of the UNOPS. And I do see the need for in-depth discussion, maybe later, and to discuss more about the way forward. And also, I can see everyone is reflecting, I mean, every stakeholder here is reflecting their anticipation on this kind of meeting. So it's very glad for us to see the recognition and to see the useful, the useful aspect of the VISUS initiative, and also as well as the assessment that we did in Chimanimani. Thank you so much to you all. So now, it's already almost the end of the webinar, and I thank you for all the participants who stayed here with us for nearly 2 hours. Actually, literally, it's already over 2 hours. I thank you so much for your support and looking forward to the continuous support and collaboration with all of you. Thank you so much. See you.
Thank you, Hu. See you.
Thank you. Bye-bye.
Thank you. Bye-bye.
Thank you. Bye.
Thank you. Thank you, Doc. Thank you very much, colleagues.